Hello, my name is David Brown, and I'll be your instructor for this course on constructivism. And to introduce myself, I'd like to tell a couple of stories about my own experiences with learning in science. When I was in college, I took a course in chemistry, and one of the topics in this course was called stoichiometry. And this is a topic that deals with balanced chemical equations and how they can help you with various calculations, such as how much of each reactant to use in a chemical reaction, how much will be produced in a chemical reaction, etc. And when I was taking the course, the professor literally said, don't try to understand all of the things going into these calculations, just follow these procedures and you'll be fine. And I ignored that advice. I have a strong desire to understand things. And so the first problem set, I literally took 3 hours dealing with the first problem. But after this, I had developed a pretty good understanding of chemical reactions and the ideas involved in stoichiometry. And so after that, I was able to solve the problems pretty easily, not because I was following rote procedures, but because I had a genuine understanding of the ideas and I was able to apply those ideas in the problems. And so this experience really got me thinking about how powerful it was to solve problems not through rote procedures, but through developing an understanding of the ideas and then applying that understanding to the solving of problems. Later in my college career as a physics major, one of my physics professors brought a group of us to an American Association of Physics Teachers conference. And while I was at that conference, I went to a session where John Clement talked about his research with students' understanding of physics ideas and the implications of that work. And I was very fascinated by this. When I graduated from college, I went to the University of Massachusetts for graduate study in physics. And while I was there, I realized that John Clement was there doing research in students' learning of mathematics and physics. And so I went to talk with him. And after talking with him and kind of thinking about my career, I realized this was where my interest really was. It was in not so much in physics research per se, but in thinking about students' learning of physics and mathematics. And so I switched over to education, but I continued working with John Clement and his research group in the physics department, looking at students' ideas in physics and mathematics. And I stayed there and I graduated and got my doctorate in education and continued working with the research group in physics on a postdoc. And after working on that postdoc for a couple of years, I then came here to the University of Illinois in 1990, and I've been here ever since. And I've had the chance to work with probably hundreds of teachers, both pre-service and in-service teachers, at all different levels, from pre-kindergarten through tertiary science and math teachers. In the course, we'll first look at some basic ideas of constructivism, which includes a strong focus on students' ideas and idea-based interactions. Then we'll look at some examples of students' ideas, learning environments that can help students' ideas to develop, and challenges in creating such constructivist learning environments. And finally, from a constructivist perspective, I don't see the lectures and readings as quote-unquote delivering content. But I'm hopeful that as you do the readings, as you listen to the lectures, as you discuss ideas with your classmates, as you reflect on the ideas through the assignments, that you'll begin to think about some new perspectives on teaching and learning that can be very powerful in helping students to develop their ideas.